Download this code from codegive.com, link in the description below. Decoding fuel pump relay problems, symptoms, diagnosis, and code examples. The fuel pump relay is a crucial component in your car's fuel system. It acts as a switch, providing power to the fuel pump when the engine needs fuel. When this relay fails, it can cause a range of drivability issues, from intermittent stalling to a complete no-start condition. Understanding the symptoms, knowing how to diagnose the problem, and even knowing how to potentially program a replacement are valuable skills for any car owner or aspiring mechanic. Understanding the fuel pump relay. Purpose The fuel pump relay acts as a high current switch. It's controlled by a low current signal, usually from the engine control unit, ECU, or other control module, that tells it when to turn on the fuel pump. The ECU sends the signal based on several factors, including key position. When you turn the key to the on position, the ECU often initiates a short fuel pump prime cycle, usually 1 to 2 seconds, to pressurize the fuel system. Engine speed, RPM. Once the engine is running, the ECU continuously monitors RPM and uses this information to determine the fuel demand. It keeps the fuel pump running as long as the engine is running. Other sensor inputs. Data from sensors like the mass airflow, MAF, sensor, throttle position sensor, TPS, and oxygen sensors influence the fuel demand calculations and, consequently, the fuel pump relay control. Location. The fuel pump relay's location varies depending on the vehicle make and model. Common locations include under the hood, engine bay, often found in a fuse and relay box alongside other relays like the starter relay, horn relay, etc. Consult your vehicle's owner's manual or a repair manual to pinpoint its exact location. Under the dashboard. Sometimes located in a relay box behind the glove compartment or near the steering column. In the trunk. In some vehicles, particularly older models, the fuel pump relay might be located near the fuel tank in the trunk. Types. Fuel pump relays are typically standard automotive relays, often with a 4 or 5 pin configuration. Some newer vehicles may use solid-state relays. 2. Common symptoms of a failing fuel pump relay. A failing fuel pump relay can manifest in various ways. The severity of the symptoms depends on the nature of the failure, example intermittent, completely open, partially shorted. 1. No start condition. This is the most common and dramatic symptom. If the relay is completely failed, it won't allow power to reach the fuel pump. You'll turn the key, the engine will crank, but it won't start. You'll hear no fuel pump whine. This is often accompanied by a lack of fuel pressure at the fuel rail. 2. Intermittent stalling. An intermittently failing relay can cause the engine to stall unexpectedly while driving. The engine might cut out for a moment and then restart, or it might stall completely. This is particularly dangerous because it can happen at highway speeds. 3. Difficulty starting. Long crank time. If the relay is providing insufficient or inconsistent power, the fuel pump might take longer to build up enough pressure to start the engine. This results in extended cranking before the engine fires up. 4. Engine hesitation or lack of power. If the relay is partially failing, it might not provide the fuel pump with the required voltage and amperage. This can cause the engine to hesitate during acceleration or lack power, especially under load, example climbing a hill, towing. This can feel like a flat spot in the acceleration curve. 5. Poor fuel economy. In some cases, a failing relay can affect the fuel pump's output, leading to inefficient fuel delivery and reduced fuel economy. This is less common than other symptoms. 6. Fuel pump noise. Whining or buzzing while fuel pump noise can also indicate a failing fuel pump itself. A faulty relay can sometimes cause the pump to operate erratically, leading to unusual noises. The pump may sound louder than usual, or it may make a whining or buzzing sound. 7. Check engine light. A faulty fuel pump relay can trigger a check engine light, but it's not always guaranteed. If the ECU detects a problem with the fuel pump circuit, example low voltage, open circuit, it might set a diagnostic trouble code, DDC. 3. Diagnosing a fuel pump relay problem. A systematic approach is crucial for accurately diagnosing a fuel pump relay issue. 1. Listen for the fuel pump prime asterisk when you turn the key to the on position, without starting the engine. Listen carefully for a brief, 1 to 2 second, whirring or buzzing sound coming from the rear of the vehicle, near the fuel tank. This is the fuel pump priming. If you don't hear it, it's a strong indication of a fuel pump or fuel pump relay problem. 2. Check the fuel pump relay asterisk. Asterisk location asterisk consult your vehicle's repair manual or owner's manual to locate the fuel pump relay. Asterisk visual inspection asterisk remove the relay and visually inspect it for any signs of damage, such as corrosion, melted plastic, or burnt contacts. Asterisk relay swap asterisk if you have a similar relay in the same fuse box, example horn relay, temporarily swap the relays. If the problem disappears, and the horn now doesn't work if you swapped with the horn relay, the original relay is likely faulty. Important asterisk make sure the relays are electrically compatible, same voltage, amperage rating. Asterisk testing with a multimeter asterisk. Asterisk continuity test, coil resistance use a multimeter set to ohms, ohmega, to measure the resistance between the coil terminals, usually pins 85 and 86 on a standard relay. A good relay will have a specific resistance value, typically between 50 and 120 ohms. An open circuit, infinite resistance, indicates a faulty coil. Asterisk continuity test, switch contacts with the relay not energized, no power applied to the coil, test for continuity between the normally open, no, contacts, usually pins 30 and 87. There should be no continuity, open circuit. Then, apply 12V power to the coil terminals, 85 and 86. You should hear a click, and now there should be continuity between pins 30 and 87. If there is no click or no continuity when energized, the relay is faulty. 3. Check the fuel pump relay circuit asterisk. Asterisk power to the relay asterisk with the key in the on position. Use a multimeter to check for 12V power at the relay's power input terminal, typically pin 30. If there's no power, trace the circuit back to the fuse box and check the fuel pump fuse. A blown fuse indicates a short circuit somewhere in the fuel pump circuit. Asterisk ground to the relay asterisk verify a good ground connection at the relay's ground terminal, usually pin 85 or 86, depending on the relay's wiring. Asterisk control signal from the ECU asterisk use a multimeter or a logic probe to check for the control signal from the ECU at the relay's control terminal, the other coil terminal, either pin 85 or 86. When the key is turned on, or while cranking, you should see a voltage signal, usually around 5V or 12V, depending on the system, that activates the relay. If there's no signal, the problem could be with the ECU, the wiring between the ECU and the relay, or a sensor providing incorrect input to the ECU. 4. Check fuel pressure asterisk use a fuel pressure gauge connected to the fuel rails test port to measure fuel pressure. Low or no fuel pressure confirms a fuel supply problem, which could be caused by a faulty fuel pump, a clogged fuel filter, or a problem with the fuel pump relay circuit. 5. Scan for diagnostic trouble codes, DTCs use an OBD2 scanner to check for any DTCs related to the fuel pump or fuel pump circuit. Common codes include *P0230 * fuel pump primary circuit, *P0231 * fuel pump secondary circuit low, *P0232 * fuel pump secondary circuit high, *P0627 * fuel pump control circuit open, *P0628 * fuel pump control circuit low, *P0629 * fuel pump control circuit high. 4. Code examples, illustrative, not directly related to relay programming. Directly programming a standard fuel pump relay is not possible. It's a simple electromechanical switch. However, in some newer vehicles, the fuel pump might be controlled by a solid-state relay or a module that is programmable. In these cases, there might be software configurations or parameters related to fuel pump operation. Here are some illustrative code examples that show how the ECU might control the fuel pump relay or interpret sensor data that affects fuel pump operation. These are conceptual and will not run directly on your car. You would need specialized diagnostic tools and manufacturer-specific software to access and modify ECU parameters. Example 1, Simulated Fuel Pump Relay Control based on RPM, Conceptual. Explanation ****. Simulation ***. This code simulates the ECU's logic for controlling the fuel pump relay. It doesn't actually interact with the real relay. *RPM and key position *. The control fuel pump function uses simulated engine RPM and K-on values to determine whether to turn on the fuel pump relay. Priming *. It simulates a 2-second priming cycle when the key is turned on. Safety *. It only keeps the fuel pump running if the engine is running, RPM 200. Millis, this is a simple placeholder that simulates the millis function, which is a function that returns the number of milliseconds passed since the program started. It is typically used in embedded systems to keep track of time. Example 2, Reading and interpreting fuel pressure sensor data, conceptual. Explanation ***. Fuel pressure sensor ***. This code simulates reading data from a fuel pressure sensor. Pressure range check ***. The check fuel pressure function checks if the fuel pressure is within an acceptable range, 35 to 65 psi in this example. These values depend heavily on the vehicle in question. Warning and actions ***. If the pressure is outside the range, the code simulates taking actions like setting a DDC or reducing engine power. Important considerations for programming, if applicable to your vehicle system. Manufacturer-specific tools *. You will need specialized diagnostic and programming tools from the vehicle manufacturer to access and modify ECU parameters. Generic OBD2 scanners cannot typically perform this level of programming. Security *. ECUs are often protected by security measures to prevent unauthorized access and modifications. You may need to bypass security protocols to program the ECU. Risk *. Incorrect programming can severely damage the ECU or other vehicle systems. Only attempt programming if you have the necessary knowledge, tools, and experience. Calibration data *. Programming may involve uploading calibration data, maps, that define the engine's operating parameters. Using incorrect or corrupted calibration data can cause serious problems. VIN coding *. Often the car's vehicle identification number needs to be coded into the ECU after replacement. This is crucial for preventing theft and ensuring compatibility with other vehicle systems. When to replace the relay vs. other components. Relay failure *. If the relay tests faulty, example open coil, No continuity when energized, replacing the relay is the obvious solution. Use a relay with the same voltage, amperage rating, and pin configuration as the original. Asterisk wiring issues. Asterisk if the wiring to the relay is damaged, example frayed wires, corroded connectors, repair or replace the wiring. Asterisk ECU problems. Asterisk if the ECU is not sending the control signal to the relay, the ECU might be faulty. This is a more complex problem that might require ECU repair or replacement. Asterisk fuel pump problems. Asterisk if the fuel pump relay is working correctly, but you're still experiencing fuel delivery issues, the fuel pump itself might be failing. Test the fuel pump's voltage and amperage draw. Replace the fuel pump if it's not functioning properly. Asterisk fuel filter. Asterisk always consider the fuel filter as a potential culprit, especially if you're experiencing fuel delivery problems. A clogged fuel filter can restrict fuel flow and cause symptoms similar to a faulty fuel pump relay. 6. Preventative maintenance. While fuel pump relays aren't typically considered a regular maintenance item, there are steps you can take to minimize the risk of failure. Asterisk keep the fuel system clean. Asterisk regularly replace the fuel filter to prevent debris from clogging the fuel system and putting extra strain on the fuel pump and the relay. Asterisk avoid running the tank low. Asterisk regularly running the fuel tank near empty can cause the fuel pump to overheat, which can eventually damage the pump and potentially overload the relay. Asterisk inspect wiring and connections. Asterisk periodically inspect the wiring and connectors in the fuel pump circuit for any signs of corrosion or damage. Clean or repair as needed. 7. Conclusion. Diagnosing a fuel pump relay problem requires a systematic approach. Start with the basic symptoms, then use a multimeter to test the relay and its circuit. Scan for DTCs to gain further clues. Remember that replacing the relay is only one possible solution. You must also address any underlying issues that might have caused the relay to fail in the first place. If your car uses a solid-state fuel pump relay, you may be able to reprogram it, but keep in mind the risks that may come with tampering with your ECU. By following these steps, you can accurately diagnose and repair fuel pump relay problems and keep your car running smoothly.